Right now, there are 39 trillion microscopic organisms inside your colon fighting for control over your choices. Every time you reach for a chocolate chip cookie, it might not be your decision at all. These microbes have a direct line to your brain through a thick nerve cable called the vagus nerve. By sending chemical signals up this pathway, they can hijack your appetite within milliseconds. In fact, researchers at UC San Francisco found that certain gut bacteria can synthesize the exact same neurotransmitters your brain uses to regulate mood and reward. If you've ever felt a sudden uncontrollable urge for sugar at 3 p.m., you've experienced this microbial mind control firsthand. Today we're uncovering the exact biological mechanism behind these cravings and how you can flip the switch in just 72 hours. If you want the real scientific truth about how your body works without the marketing fluff, subscribe to the channel right now. Let's get into it. To understand this invisible puppet master, we have to look at the highway connecting your gut to your head. This is the gut-brain axis, a two-way communication system driven by biochemistry. Consider the genus Lactobacillus, which can produce GABA, the brain's primary calming neurotransmitter. When these bacteria run low on prebiotic fuel, they send distress signals that your brain interprets as anxiety. To relieve this sudden restlessness, your brain prompts you to seek out quick energy, often leading to a high-carb binge. This creates a feedback loop where the microbes that thrive on simple sugars force you to feed them. Conversely, beneficial species like Akkermansia and Muciniphila act as guardians of your intestinal lining. They consume the mucus layer, stimulating your body to produce more of it and keep the gut wall strong. When you feed these beneficial bacteria dietary fiber, they ferment it into short-chain fatty acids, or SCFAs. These molecules are the primary currency of gut-brain communication. One specific SCFA called butyrate serves as the primary fuel source for the cells lining your colon. Without it, your gut wall weakens, allowing toxins to leak into your bloodstream. Another SCFA, acetate, travels through your circulation, crosses the blood-brain barrier, and directly targets the hypothalamus to signal fullness. It acts as a natural biological brake on your appetite. When your diet lacks diverse plant fibers, these SCFA-producing bacteria starve, and that vital appetite brake is lost. You end up feeling constantly hungry, even after consuming thousands of calories. The physical degradation of the gut barrier triggers a response from your immune cells. Over 70% of your immune system resides directly along the intestinal tract. As the barrier fails, fragments of bacterial cell walls, known as lipopolysaccharides, or LPS, enter your system. This initiates a state of chronic, low-grade systemic inflammation. This inflammation does not stay in your abdomen. It travels to your brain and disrupts your mood. Inflammatory cytokines can block the synthesis of serotonin, leading to feelings of lethargy and sadness. Remarkably, over 90% of your body's serotonin is produced in the gut by enterochromaffin cells. These cells rely on microbial cues to release this critical mood-regulating chemical. To prove this connection, scientists at the University College Cork performed fecal microbiota transplants from depressed humans into healthy rats. The recipient rats quickly began exhibiting classic signs of anxiety and depression. This research demonstrates that your emotional state is not just a reflection of your thoughts, but of your microbial ecology. A compromised microbiome actively alters how you experience the world. The good news is that this ecology is highly dynamic and responds rapidly to dietary changes. You can begin restructuring your microbiome in as little as 24 hours. The primary driver of microbial diversity is the variety of plants you consume. According to the American Gut Project, individuals eating more than 30 distinct plants per week have the healthiest microbiomes. In contrast, the standard American diet, heavy in ultra-processed foods, acts like a monoculture crop. It starves out specialized bacteria, leaving only the species that feed on refined sugars. This explains why relying purely on willpower to resist cravings is a losing battle. You are fighting the survival instinct of trillions of hungry microbes that want to keep living on sugar. Instead of fighting them, you must outpopulate them by selectively feeding their competitors. Introducing prebiotic fibers like inulin and resistant starch is the first step in this process. These fibers act as targeted fertilizer for beneficial bacteria, encouraging them to multiply rapidly. As their numbers grow, they physically crowd out the sugar-seeking microbes. You will notice the shift first in your daily energy levels. As inflammation subsides, the brain fog associated with a leaky gut begins to lift. Moreover, your taste buds will actually change as your microbiome shifts. The intense cravings for sweet foods start to fade as the microbes demanding them decrease in number. This is not a theoretical concept. We can measure this transformation through advanced stool testing. Tracking markers like secretory IgA and short-chain fatty acids provides a clear picture of recovery. By focusing on nurturing your inner ecosystem rather than calorie restriction, you work with your biology instead of against it. Sustainable health starts from the bottom up. In the next phase of our protocol, we will examine the specific probiotic strains that directly influence sleep quality and stress resilience. Your gut bacteria aren't just sitting there digesting fiber, they are actively manufacturing neurotransmitters like GABA and serotonin. In fact, about 90% of your body's serotonin is produced in your digestive tract, not your head. But this serotonin doesn't cross the blood-brain barrier directly. Instead, it stimulates the vagus nerve, a direct superhighway running from your colon straight to your brainstem. Think of the vagus nerve as a high-speed fiber optic cable transmitting electrical impulses at over 200 miles per hour. When gut microbes release metabolites, they send instant signals that modulate your emotional state. Specifically, certain bacteria like Lactobacillus rhamnosus produce GABA, your brain's primary inhibitory neurotransmitter. This compound acts like a molecular brake, lowering your heart rate and reducing feelings of anxiety. When researchers cut the vagus nerve in preclinical models, the calming effects of these bacteria vanished completely. Without this physical line of communication, the brain remains completely deaf to the gut's chemical messages. But the communication isn't just one way. Your brain can also send signals down the vagus nerve to alter the acidity and transit time of your digestive system. Under high stress, your sympathetic nervous system triggers a fight or flight response, reducing blood flow to your stomach. This sudden drop in oxygen levels alters the local ecosystem, favoring opportunistic pathogens over beneficial strains. These pathogens thrive in an inflamed, oxygen-depleted environment. As they multiply, they begin to secrete toxins that damage the tight junctions of your gut lining. This condition, known clinically as increased intestinal permeability, allows partially digested food proteins and bacterial debris to leak directly into your bloodstream. Your immune system immediately treats these particles as foreign invaders, launching a systemic inflammatory response. This low-grade chronic inflammation doesn't stay confined to your abdomen. Inflammatory cytokines can cross the blood-brain barrier, triggering microglial cells to become hyperactive. Once activated, these microglial cells destroy healthy synapses, leading to what we experience as brain fog and chronic fatigue. It is a physical disruption of brain structure caused by an imbalanced digestive tract. Furthermore, this state of systemic inflammation impairs your brain's ability to utilize dopamine, the neurotransmitter responsible for motivation and reward. Suddenly, activities that used to bring you joy feel dull and unappealing. To compensate for this dopamine deficit, your brain begins to crave fast, highly concentrated sources of energy. This is where your microbiome steps in to hijack your decision-making process. Different species of microbes require different nutrients to survive and reproduce. For instance, Prevotella species thrive on simple sugars, while Bacteroidetes prefer complex fibers. If your diet is high in processed foods, you selectively feed sugar-loving bacteria, allowing their populations to swell rapidly. These microbes then synthesize specific peptides that mimic your body's hunger hormones. These chemical mimics travel through the bloodstream or stimulate vagal endings to reach the hypothalamus, the brain's appetite control center. They alter your taste receptor sensitivity, making sweet foods taste even more rewarding. It is a highly sophisticated form of biological manipulation. You believe you are making a conscious choice to eat a donut, but you are actually fulfilling a molecular command from your microbiome. In contrast, feeding your gut with diverse fibers promotes the growth of species that produce short-chain fatty acids, or SCFAs. The three primary SCFAs are acetate, propionate, and biurate. Biurate is particularly powerful, serving as the primary energy source for the cells lining your colon. It strengthens the gut barrier, preventing the leakage of inflammatory toxins into your system. Propionate travels to the liver, where it helps regulate glucose production and increases the release of satiety hormones like peptide YY and GLP-1. Yes, the very same GLP-1 that modern weight loss drugs try to mimic. Acetate crosses the blood-brain barrier directly, entering the hypothalamus to signal that you have received enough energy. This naturally suppresses the urge to overeat without requiring willpower. This means that the key to managing cravings isn't white-knuckle self-discipline, it's changing the composition of your internal ecosystem. By shifting your microbial balance, you naturally shift your appetite. But how quickly can this ecosystem actually change? Studies show that major dietary shifts can alter the relative abundance of microbial species within just 24 hours. However, these rapid shifts are highly unstable. If you return to your old eating habits, your microbiome will revert to its baseline state just as quickly. To create permanent change, you must consistently provide the specific substrates that beneficial bacteria need to build stable communities. This process is called prebiotic feeding. Unlike probiotics, which introduce external bacteria that often fail to colonize, prebiotics are non-digestible fibers that nourish your existing beneficial strains. They act as targeted fertilizer for your inner garden. Excellent sources of these prebiotic fibers include chicory root, Jerusalem artichoke, garlic, onions, and underripe bananas. Incorporating even small amounts of these foods daily can dramatically boost butyrate production. Additionally, polyphenol-rich foods like dark berries, green tea, and extra virgin olive oil act as powerful, selectively feeding agents. They promote the growth of Akkermansia mucinifera, a keystone species for metabolic health. Akkermansia is unique because it feeds on the protective mucus layer of your gut, stimulating the body to constantly produce fresh, thick mucus. This maintains a robust physical shield against pathogens. As this protective barrier strengthens and inflammation subsides, your dopamine receptors begin to recover their normal sensitivity. You'll find that your mood stabilizes and intense cravings simply fade away. To understand how this dialogue happens, we must look at the vagus nerve, the primary physical superhighway connecting your gut to your brain. This nerve functions like a bidirectional fiber optic cable, but 80% of its signals travel upward from the gut, not downward from the head. Take Sarah, who believes her intense 3 p.m. craving for a chocolate chip cookie is a conscious decision or a lack of willpower. In reality, the microbes in her colon are running low on simple sugars and are firing signals up the vagus nerve to force her to find quick energy. These microbes aren't just passive passengers, they can synthesize neuroactive molecules that directly mimic the brain's own signaling chemicals. For instance, certain strains of Escherichia coli produce a protein called CLPB, which acts as a molecular copycat of a hormone that regulates appetite. When CLPB enters the bloodstream, it influences the hypothalamus, tricking Sarah's brain into feeling a fake, urgent state of starvation. This bacterial manipulation goes beyond hunger, directly altering neurotransmitters that control your daily emotional stability. In fact, 90% of your body's serotonin, the key neurotransmitter for mood and satisfaction, is synthesized in your gut. Specialized cells in your gut wall, called enterochromaffin cells, manufacture this serotonin, but they cannot do it without bacterial stimulation. The primary triggers for this production are short-chain fatty acids like butyrate, which are created when beneficial microbes ferment dietary fiber. If Sarah eats a standard processed diet containing less than 15 grams of fiber daily, her butyrate production plummets. This drop in butyrate starves the cells lining her colon, causing the cellular tight junctions to degrade and become porous. This condition, commonly known as leaky gut, allows endotoxins like lipopolysaccharide, or LPS, to slip into her bloodstream. LPS is a highly inflammatory compound from the cell walls of dead bacteria that can travel to the brain and disrupt the blood-brain barrier. Once inside the central nervous system, LPS triggers microglia, the brain's immune cells, causing them to release inflammatory cytokines. This low-grade neuroinflammation is the exact biological mechanism behind the sudden onset of brain fog, irritability, and anxiety. It explains why eating a single $15 fast food meal can measurably worsen your mood and mental clarity within just 3 hours. But the gut microbiome has another trick to calm this inflammation, utilizing a neurotransmitter called gamma-aminobutyric acid, or GABA. GABA acts as the nervous system's natural brake pedal, slowing down overactive neurons to reduce anxiety and stress. Certain beneficial gut bacteria, particularly Bacteroides species, are highly efficient at converting dietary glutamate into active GABA. While this gut-derived GABA cannot cross the blood-brain barrier directly, it stimulates the local vagal receptors in the gut wall. This stimulation sends a direct signal to the amygdala, the brain's threat detection center, effectively turning down the alarm. When these specific Bacteroides strains are wiped out by antibiotics or chronic stress, this calming signal disappears entirely. Without that microbial break, Sarah's amygdala stays hyperactive, making minor daily stressors feel like major emergencies. To cope, her brain demands immediate comfort, initiating a cycle where stress alters her microbiome, which in turn amplifies her anxiety. Breaking this loop requires repairing the gut barrier, which is regulated by a protein called zonulin. Zonulin acts as the gatekeeper, opening and closing the spaces between the cells of the intestinal lining. Certain triggers, such as wheat gluten and specific pathogenic bacteria, cause an overproduction of zonulin, keeping the gut gate stuck open. This constant exposure to leak particles keeps the immune system in a state of high alert, laying the groundwork for insulin resistance. Think of the vagus nerve as a high-speed fiber optic cable running directly from your gut to your brainstem. It transmits signals in milliseconds, bypassing the bloodstream entirely. Through this connection, your microbes can stimulate the release of serotonin, the chemical responsible for your mood and satiety. In fact, over 90% of your body's serotonin is synthesized right in your gut. But this gut-derived serotonin cannot cross the blood-brain barrier. Instead, it acts as a local messenger, activating vagal receptors that send a sensory signal up to your head. Another key pathway involves short-chain fatty acids, or SCFAs, which are byproduct compounds created when your bacteria ferment dietary fiber. These molecules travel throughout your body to regulate energy metabolism. Butyrate, one of the most critical SCFAs, serves as the primary fuel source for the cells lining your colon. This keeps your gut barrier locked tight, preventing unwanted molecules from leaking out. When your gut barrier is compromised, toxic cell wall fragments from dying bacteria, called lipopolysaccharides, escape into your bloodstream. This is the origin of systemic endotoxemia. Once these endotoxins reach your brain, they breach the blood-brain barrier and trigger specialized immune cells called microglia. This activation causes low-grade neuroinflammation, which you feel as brain fog. This means that afternoon brain fog isn't just mental fatigue. It is often a direct inflammatory response to a leaky gut barrier. Your cravings are also controlled by this axis. They are actually survival strategies used by different bacterial species. Microbes want the specific foods that help them multiply. For example, Prevotella bacteria thrive on simple sugars, while Bacteroidetes prefer complex prebiotic fibers. Whichever species dominates will dictate what you crave. If you refuse to feed sugar-loving microbes, they can produce toxins that make you feel physically uncomfortable or anxious. They use chemical coercion to get what they want. Once you give in and eat that cookie, these microbes release reward signals that trigger a dopamine spike in your brain. You think you made a choice, but you just rewarded their behavior. To counter this, your gut has enteroendocrine cells that monitor incoming nutrients. When they detect fiber, they release satiety hormones like peptide YY and GLP-1. GLP-1 is the exact hormone that blockbuster weight loss drugs mimic to switch off appetite. Your gut can produce it naturally when fed the right ingredients. However, a diet high in processed foods starves these hormone-producing cells, leading to a drop in natural GLP-1. Without this signal, your brain assumes you are starving. This explains why willpower alone rarely works for weight loss. You cannot out-discipline a hormone deficiency triggered by your microbiome. Interestingly, 90% of the signals traveling along the vagus nerve are ascending. Your gut is talking to your brain far more than your brain is talking to your gut. This bottom-up communication is why a sudden shift in your microbiome can trigger unexpected anxiety within hours. Your brain is simply translating gut distress into worry. Conversely, chronic psychological stress releases cortisol, which alters the physical environment of your gut. This hormone damages the protective mucus layer where beneficial bacteria live. When that mucus layer degrades, opportunistic pathogens take over, causing further inflammation. This establishes a feedback loop where stress breeds bad gut bacteria, which in turn breeds more stress. To break this loop, you need to improve your vagal tone, which represents your nervous system's capacity to relax. A higher vagal tone helps keep your gut barrier intact during stressful events. Studies show that specific strains like Lactobacillus rhamnosus can actually increase GABA receptors in the brain's prefrontal cortex. This is done entirely via the vagus nerve. GABA is your brain's primary inhibitory neurotransmitter, acting like a natural brake on anxiety and stress. By altering your gut microbes, you are directly adjusting your brain's chemistry. This modulation also impacts how your body handles calories. Short-chain fatty acids bind to specific receptors on your fat cells, signaling them to stop hoarding energy. Propation, another SCFA, travels to the liver where it helps regulate gluconeogenesis. This prevents sudden spikes and crashes in blood sugar, stabilizing your energy levels. When your gut lacks the microbes to produce propation, your liver goes into overdrive, producing excess glucose that gets stored as visceral fat. This is the fat that wraps around your organs. Visceral fat is highly metabolic and releases inflammatory cytokines that further damage your gut lining. It is a metabolic trap that begins with a silent shift in your microbiome. Even your resting metabolic rate is affected, as a dysbiotic gut can reduce daily calorie burn by up to 100 calories. Over a year, this minor shift can lead to 10 pounds of fat gain. This is why two people can eat the exact same meal and have completely different metabolic responses. One person's microbiome is burning the energy, while the other's is storing it. In the next section, we will look at how your immune system acts as the ultimate mediator between these two complex systems. This cellular communication isn't theoretical. It happens via a physical superhighway called the vagus nerve. Think of the vagus nerve as a bidirectional fiber optic cable running directly from your colon to your brainstem. For decades, we believed the brain did 90% of the talking on this line. But recent tracing studies show that a staggering 80% of the traffic is actually traveling upward from gut to brain. Your microbes aren't just passive passengers, they are active dispatchers, sending encrypted chemical text messages. They do this by producing metabolites like butyrate, a short-chain fatty acid generated when bacteria ferment dietary fiber. Butyrate stimulates the cells lining your gut to release a hormone called GLP-1. Yes, that is the exact same satiety hormone that synthetic weight loss drugs mimic for thousands of dollars a month. This hormone binds to local vagal endings, instantly signaling your brainstem that you are full. But what happens when you starve these beneficial fiber-loving bacteria? The butyrate supply plummets, GLP-1 production drops, and the vagal pathway goes silent. Without that chemical break, your brain assumes you are starving and enters a state of chronic alarm. Suddenly, opportunistic microbes that feed on simple sugars take over the territory. These sugar-loving species can synthesize their own neurochemicals, including dopamine, to manipulate your behavior. By releasing dopamine near gut nerve endings, they trigger a craving loop that forces you to reach for the donut. It feels like a lack of willpower, but it is actually a precise evolutionary hijacking of your reward system. The cravings stop only when the target bacteria receive the glucose they need to replicate. But this bacterial influence extends far beyond hunger and food selection. Microbes also manufacture over 90% of your body's total serotonin, the molecule responsible for stabilizing mood. While this gut-derived serotonin cannot cross the blood-brain barrier directly, it acts on local nerve endings to alter brain activity. Specifically, it modulates the firing rate of the vagus nerve, directly influencing the brain's emotional centers. At the same time, certain strains of lactobacillus produce GABA, the brain's primary inhibitory neurotransmitter. GABA acts like a natural Valium, calming overactive neural circuits and reducing baseline anxiety. When researchers in a 2011 study severed the vagus nerve in mice, all the psychological benefits of these bacteria vanished. This proved that the physical connection is mandatory for microbial mood regulation. So when your gut lining is inflamed, the physical connection degrades and the signals get corrupted. LPS, an inflammatory toxin from bad bacteria, leaks into your bloodstream and breaches the blood-brain barrier. Once inside, it activates microglial cells, triggering low-grade brain inflammation that manifests as brain fog. This explains why patients with irritable bowel syndrome suffer from clinical depression at triple the average rate. Fortunately, you can rewrite this entire neurochemical script in less than a week. So how do we stop these microbial puppet masters from hijacking our cravings? It starts by cutting off their favorite fuel source, highly processed sugars. When you starve these opportunistic bacteria, they can no longer send urgency signals to your brain. Instead, we must feed the beneficial strains using prebiotic fibers like inulin, found in chicory root. These fibers act as molecular building blocks for a crucial class of compounds called short-chain fatty acids. Specifically, your gut bacteria convert these fibers into butyrate, which directly stimulates the release of satiety hormones. In fact, this natural process triggers the exact same GLP-1 hormone that popular $1,000 weight loss drugs replicate. But you don't need a weekly injection when you can produce this natural appetite suppressant right in your colon. We also need to actively rebuild our gut diversity by introducing fermented foods. Eating just 2 servings of unsweetened kefir or sauerkraut daily introduces billions of live, beneficial bacteria. These new residents outcompete the sugar-loving microbes, weakening their hold on your dopamine pathways. Think of it as restoring order to a chaotic ecosystem where the loudest voices have been running the show. To keep this ecosystem thriving, aim to consume at least 30 different plant-based foods each week. This variety ensures that no single bacterial strain dominates, stabilizing your mood and energy levels. Over time, your brain stops receiving constant emergency signals for quick glucose hits. You will find that willpower is no longer a daily battle because your gut is no longer fighting you. This is the true power of the gut-brain axis. Biology, not sheer discipline, dictates your choices. By changing what you feed your microbiome, you are directly rewriting your brain's daily chemistry. Now you know the secret mechanism. Those intense cravings were never a lack of willpower, but the biochemical commands of your gut bacteria. Like this video if you're ready to take back control, tell us in the comments if you prefer kefir or sauerkraut, and subscribe to unlock the science of your metabolic health in our next episode.